Okay, guys, so let's start. My name is Maciej Lasyk, and today I'd like to tell a story of no-ops company I work for and how we approach the reliability here in Codewise. So I lost focus here. Weird. Very weird. Okay, so reliability engineering. What's that? Actually, maybe from the beginning. I've been an engineer for like 20 years right now, and my area of expertise right now is specialty reliability. And for me personally, software craftsmanship is not only about developing a software and creating a software, but it's also about everything that is later. So maintenance, making sure that the service is always uptime, always on, and that kind of stuff. So how can we learn about reliability? So this very smart person, I'm quoting him because I was studying physics here in Jagiellonia University, so it's let's say my area. He told that once that if you wanna be an expert in some area, then you should, or you would have to commit all possible mistakes in that very narrow area you are working on. However, in case of reliability in software engineering, it is not the best approach, because if you commit all mistakes, then probably your business is already down. I mean, it's already shut down or something. So maybe another way. And there is a book I read like almost 10 years ago. This is a book written by authors of the whole DevOps movement. One from which is John Ospo. And from this book, you can actually learn about all the major things that reliability is related with. So basically, you can learn about CI/CD and how our visitors feel and how to measure that. Meaning that 10 years ago, they were already talking about that the reliability thing is all about how visitors feel our services, not about how we see it in my monitoring systems, but how visitors see it. You will find also the chapter about database reliability, which is very cool and very important. Cloud computing, even though AWS services were just starting then, and agile infrastructure, etc. So I usually recommend you to read it if you haven't yet. Okay, so reliability engineering at Codewise. 2 years ago, I was hired in Codewise, and I was as the first non-strict developer person, and I was given a chance to enter this no-ops world, which was in 100% hosted in AWS services, and it was there. So from one perspective, I was like this Alice entering the Wonderland, because I was very curious and a bit scared, because we had, and I mean we still have, huge amount of traffic. It's like 300,000 requests per second on average on all our services. Is a really huge amount of traffic, and some other numbers. This 1K of EC2s is about those big ones, EC2s, etc., etc. So after a few days of onboarding, I started seeing things, and I started asking questions. My first thing to work on was to actually find me a job. I mean, I was told, hey Maciek, you know what, now when you're hired, just go through guys and ask them, and find yourself a job. There's a plenty for you, that's for sure. Okay, so in terms of reliability, I quickly find out that we have two databases. Actually, one database and one clustered NoSQL. It was etcd and Cassandra. And I found out that those are the major reliability threats in whole company, because its reliability didn't scale with the growth of the company. And 2 years ago, we were growing like, whoa, yeah. And that was basically my job. Okay, so the Wonderland of Codewise. Oh, I could be telling about that. Okay, so first thing, I found out developers are on call. We don't have SRE teams, we don't have system administrators or anyone else. Developers are doing 100% of the maintenance. And yet we created our own database called VolumeDB. Yeah, because we can and because why not? And also we self-host Cassandra and etcd clusters without system administrators and reliability engineers. And we also have our own monitoring solutions. Yeah, we created 2 of those called Hyperion and Sentinel. And let's say that those were the major reliability related things I found out after 1 week or 2 or something. So how did I approach the whole reliability engineering in the Codewise after that? I decided that we'd have to find the major reliability threats over all services. So I had to get along all guys, all the products, and ask how do they work, and just try to understand how reliability looks like. For instance, from the business perspective, the most important thing is that not that we have a 5 minutes of downtime, that's acceptable completely. But if we have a downtime and then we can't really get back from that downtime because, for instance, we don't have working backups or something like that, then business is off. So yeah, that was those kinds of things I was looking for. And I tried to describe those things in an understandable way for business, because business is not always technical. Yeah, so for starters, I already know those 2 books, which I also highly recommend for you. Google published those a couple of years ago. The one of the left side is the theoretical book, and it's not that short. And the one of the right side, published later, is about practice of reliability, how to do that in practice. Actually, both of those are a bit over-engineered for me, and not only for me, but I highly recommend. Over-engineered maybe because those are created for the scale of Google. They basically tell how they approach the reliability thing at Google among many years. Other thing, if you don't have time or don't want to read 2 books, you can sign up for the Coursera course. It's $50 or something right now, and it's 4 hours per week, something like that. And I really recommend this one even more than books if you are lazy like me, because it's gonna tell you about reliability, about the most important things. Okay. Okay, so let's go further. What is reliability about? Basically, from Google perspective, from what I learned after many years, it's about how our users are happy. Are our users happy, and how to measure that? Because in the end, the most important entity in whole business is the user. Yeah? Another thing, from business perspective, how much reliability-related work is required? Because we know that features are the most important besides users, but features drives users acquisition. So how much reliability-related work is required, because we don't want to do that. We don't have time for that. And also how to maximize effort on this feature development. So, in theory, SREs, in Google world, SREs takes care of product reliability. Googlers have SRE teams. Facebook have production engineering teams. LinkedIn, as far as I remember, also production engineering, something like that. And in that world, SREs takes on call. They do on calls. Before allowing any service to production, they have those reliability checklists. So if you create new service, you have to fill all the fields from the reliability checklist, and then SRE team will accept it on production. And SREs can ask developers for help when something bad happens, when system is down and they can't handle it themselves. Okay. So in our company, developers are SREs because we are on call. CRE principles. CRE stands for Customer Reliability Engineering. It's a part of engineering in the Google's theory. And those three principles, in my opinion, are the most important from this whole CRE movement. First one, reliability is the most important feature. If you can agree on that with your business, then you just win. Simply because, why is that? When your service is down, then no matter what kind of features it has, it's just down. It doesn't work. So yeah, it is most important. And if business understand that, then it's cool. And the other thing, users not monitoring the site reliability. And I understand this in this way. If someone tells you it doesn't work for me, then you don't reply with it works for me. But you start thinking, why doesn't it work for him? Maybe because our monitoring, which tells that everything is fine, doesn't work in South America, and it just doesn't show us how it works there, etc., etc. So basically, always listen to a user. Next thing, in order to increase availability, you have to know a couple of very important things. First of all, if you craft a software, let's say a Java application, in the most perfect way, then you can achieve like 3 nines. So let's say 40 minutes of unavailability. It's a theory, it's a statistical thing solved by Google's, but it's actually understandable because imagine you have this jar, you put it onto Java onto some virtual machine, and then you start it. And without any operability, when this machine is down, or you have out of memory or something like that, you are down. And in 1 month, you can really achieve that 40 minutes of unavailability. Okay, so if your business has greatly engineered operations, like operations teams, SRE teams, etc., then you can have even 4 nines. It's like almost 5 minutes of unavailability. Why? Because, for instance, you are using auto-scaling groups, or you have operations team that does it for you. So yeah. And the price of 5 nines is really, really huge. You have to work in greatly engineered business. And why is that? Simply because for 5 nines, you need 2 things. High level of automation, and the second is self-healing. Basically, if something goes off, it has to self-heal in matter of milliseconds, even not seconds. And in order to do that, your business have to provide money for that, because it's really expensive to provide that kind of automation and self-healing. So it's not like you will always need these 5 nines, and not every business can afford 5 nines. Maybe 4 nines is just okay for you. And above that time is error budget. Error budget means it's a time you agree with your business on downtime. For instance, in terms of 4 nines, you agree with your business that you can afford 4 minutes of downtime, and that's fine. And you put it on SLA, and that's cool. Okay. SLAs. What's that? That's basically agreement on unavailability with your customers. You put it on papers, and that's all. If, for example, we agree that one of our services, ZeroPark, can be down for 1 hour, and that's even not 4 nines of availability. That's actually not true. Okay. SLOs, it's measurement characteristics. Basically, if you have SLA and you agree on something with your customer, then you have somehow to measure it. So this is SLO. This is what SLO is for. Basically, we measure in percents, because it's very easy to discuss about percents with your business and with any other entity in your company. And SLO is successful events, meaning let's say we define successful event as a request that finished under 200 milliseconds, and that's fine. Okay, so that's the successful event, and valid event would be all those events that we care about. So for instance, we don't care about Googlebot, because we don't, and we don't care about some batch jobs, because we don't, and then we count those valid events and give it in a percent. And the last thing, SLI, in order to conform with SLOs, we have to somehow measure that SLOs. And SLI are basically the low-level checks in your monitoring systems, whatever you use. and it's a measurement of user expectations. So basically, you would measure how fast your systems behave. So for instance, you measure the latency or throughput or whatever. Okay, so about error budget. Basically, you agree on error budget starting from your SLA, and if you don't have SLA, so maybe from SLO. If you have SLA, let's say for telling that you agree on that 1 hour of unavailability, then you would set SLO for 99 for 4 nines, because that's cool. And then you can tell your development teams that, okay, guys, you've got 1 hour of error budget in this month, and that's the number of that's the time systems can be offline. And it could be graphed like this. Okay, and for instance, product manager together with engineers defines an SLO, so the expectation of target uptime per month. Secondly, the actual uptime should be measured somehow by some third-party tool like Tornimo, which is our internal tool, or Datadog or whatever. The difference is the budget, how much unreliability is remaining for the month. And what happens then? If there is still error budget remaining, then you focus only on features development because everything is cool. But if we drain the error budget, then all hands on deck. You stop working on the feature development, and you must work on the reliability. And if you have a list of your services, the error budget table could look like this. It's just an example. And our business, after talking to them, they told us this thing that, okay, so we'd like to see everything on one screen. So it's also just an example, even not ours, but how you could visualize the reliability on one page. You would have the SLOs, you would have the error budget, and some key metrics. About the toil. Toil is this manual and repetitive work that could be automated. Also non-tactical and reactive. Basically, all the things that you work on that you wouldn't like to work on because it shouldn't be there. For instance, if you have to restart your Java applications because of out-of-memory errors, it's a toil. If you have to solve the first world issue, disk run out of space, it's a toil. If you have a flapping monitoring telling it works, it not work. It doesn't work. It works, it doesn't work. It's a toil. And Asari defines toil as a waste. So we don't want to have a waste, and it should be removed by automation. But be warned, you can work on automation and put a huge amount of job into that automation, and in the end, it doesn't work, and you have to put even more time into that automation. So you have to think really good whether that kind of toil should be automated and how. Automation is tricky. Okay, so DevOps and SRE. Is there any DevOps engineer in this room? Okay, guys, stand up. There is one. Please, everyone, stand up. Yeah, stand up from your chairs. Like everyone, please, guys. There is some point I would like to underline here. Okay, and now repeat after me. No, keep standing and start repeating. I will not call anyone DevOps engineer ever again. Okay, guys, DevOps, thank you, you may sit down. Guys, DevOps is a practice of operations. It's how we work between development and any other guys. Operations, security engineers, network engineers, business, etc., etc. It's about participating together in the entire life cycle. So you can't call anyone a DevOps engineer. You can't create a DevOps team. I mean, it's not like this. DevOps, it defines the overall behavior. I mean, how we approach work, how we communicate. DevOps is a meta class. And SRE is implementing that metric class. SRE basically tells you in details how to work on the reliability thing. So remember, don't call anyone DevOps. Okay, database reliability. There is a book published 1 year ago by Charity Majors, who is a very famous person in the reliability and DevOps world. She knows really huge amount of things about database reliability, and I also recommend reading it and reading her blog, which is quite cool. And she now also works in the company called Honeycomb, which is about observability monitoring, etc. Also quite cool thing. Okay, let's jump into Cassandra finally. Cassandra basics. How many of you knows Cassandra, used it or something? Okay, not that many of you, like 4 or 5 people. Cassandra is a distributed database. And about Cassandra, from my perspective, it's an operability hub. I mean, I've been operating the BMSs like Oracle, like MySQL, PostgreSQL, etc., really a lot of that. And I got quite a bit of experience. And when I first touched Cassandra, I asked myself, what the hell? I mean, who created this? It's not created for operating. Okay, so the first thing is a data model. Actually, yeah, data model, and there are 2 main rules, 2 contradicting rules. First, spread all data evenly around the cluster. Cluster means we've got number of nodes around the cluster, because it's a ring cluster, and you would like to spread the data evenly. Why? Because you would like every node to have, let's say, the same level of performance, the same level of pressure. And the second rule, minimize the number of partitions read. But partitions are groups of rows, as you can see here. There is one partition key and there are groups of rows. So when you issue a read query, then you want rows to fetch then you would like to fetch as less partition key as possible. Why? Because partitions are distributed among the whole cluster. And in practice, it works like this. Your client issue a read query, and you hit one node, and this node then is the node who actually starts negotiating with other nodes. Okay, do you have this partition? No. Do you have this partition? Yes. Do you have this partition? Yes. Do you have to? No. And he have to do all that job. And it's time-taking, time-consuming. That's why we have to minimize the number of partitions reads. And those rules are conflicting with each other. So you basically have to find the sweet spot. And let's say that you don't know Cassandra and you start developing an application using Cassandra. And this is not that easy thing. It's the first actually problem you have with that. Okay, next thing, data modeling. Again, 2 rules that may be not that obvious. First, optimize data model for queries, not like RDBMSs when you optimize for schema, let's say, and you first build schema and then you think, how to get data from that. In Cassandra world, you have firstly think, what do you want to do? What do you want to get from that database, from that table? And then you create a schema. That's completely fine to duplicate data in the Cassandra world because there are no joins and storage is very cheap comparing to CPU, memory, etc. And also don't minimize the number of writes. In normal RDBMSs, you always optimize the number of writes because the write is the heavy thing here. You have that indexes, etc., and the writes are time consuming. In Cassandra world, Cassandra is highly optimized for writes. You can achieve like 1-2 milliseconds of writes even though you are writing a couple of 100 times per second. It's quite cool. So optimize for reads. Another thing, replication factor, what's that? In Cassandra, when you issue a query, read or write query, that's no matter, then you tell how many of replica of that kind of data, of the part of data you would like to have. So for instance, in this example, we've got 4 in US East data center. Let's say that this ring is US East. And from the coordinator is told, okay, we want to have 4 replicas, so then data is written to node and in the clockwise fashion into the sibling nodes. So 1, 2, 3, 4, and that's cool. And also you can have the replication to another data center is grayed out, so it would be like another data center, another link somewhere there. That's about the replication factor. What about that tunable consistency people are talking about? Basically, we can also per operation read or write set. Read or write. Replication factor is per key space. Yeah. Tunable consistency is per read and write. You can tell what kind of consistency you would like to achieve. So, for instance, if you're writing a data, you would like to tell, okay, I want all nodes in the cluster confirm that they receive the data, and that would be the all consistency level, strong consistency, and you would have to pay the higher latency price for that. And the other side, you got the one level of consistency. It's called eventually consistent. Basically, if you write or if you read, then only one node replies to you, okay, it's fine, yes, I did that. So eventually data will be replicated according to that replication factor. Eventually. Why not right now? Because later. But if you agree with that, that's cool. Okay. Okay, so now about setting up this whole reliability thing in Codewise, because right now we are about after the theory part and after the Cassandra theory part. So yeah, problem with this whole site reliability engineering for Google is that we are not Google size. We are like 100 and something, 150 maybe people. And Google SRE model was prepared for a large scale company that maintain reliability teams, and we don't. So for me, yeah, it was an overwhelming theory, and I wanted to make sure that in terms of Cassandra, people are not woken up. So basically, how to provide reliability for Cassandra so they don't have operate with that during night or something. So as always, we customize everything. We don't just take things for granted. So we customized the reliability model. And we created SRE group, Site Reliability Engineering group, among our teams, our development teams. We meet every week, every 2 weeks, and we discussed what needs to be done. In the first meeting, we created the roadmap meeting, let's say, and we discussed how we see reliability of our products, of our services, etc. We just put the post-it notes. I wanted to understand how our developers understand reliability. So we put some post-it notes, then we vote for what's the most important thing, and then we started our meetings. First thing, that's kind of interesting. The most important thing for people was self-healing. Why is that? I assume personally, it's just my comment, that it is because they are on call. So they would like not to be woken up during night. So yeah, and improve monitoring, high availability, etc. Okay. And yeah, this is the listing of, let's say, 11 meetings and how it was going. Hello world, it was just telling hello and what is reliability all about. The second meeting was about roadmap, the third also, and then we started normal agenda, self-healings, etc. Problem I saw was that we had, and we still have, the reliability mindset amongst company. I mean, we have people who have this reliability mindset. If they work on the service, they think about the reliability of it. But we didn't have the reliability culture, so we didn't share the knowledge at the proper level. We didn't talk between teams about how we solve reliability issues. I mean, it happened, but it happened like when we met in the kitchen or when we read Slack channel after some outage or something. But we didn't have this kind of events, this kind of meetings. Another thing, the postmortems. Postmortems are meetings that you perform after an outage when you discuss what went wrong, why did this went wrong, how it was solved, and what to do to prevent it in the future. Postmortems, in my opinion, are not always needed. Those are just needed when business was impacted. I mean, when customers couldn't use our products. So this whole thing about do postmortems every time, I mean, it's just burning of your time. Everything you need is just to understand the problem and make sure it doesn't happen again. And also, during those post-mortem meetings, also during our SRE meetings, we have this one rule: attack the problem, not the people. So no blameless post-mortems, blameless meetings, etc., etc. Okay. And how did we set up the reliability? So we also we started working on the service catalog. It's a service catalog from our infrastructure team, and basically we put there every service we have. It's just a part, tiny part of all our services, and we started filling those gaps about self-healing, about monitoring, where is the repository for infrastructure, for deployment, etc., etc. So basically, everyone in the company can actually see how every other service works and learn from it. This way we started building a SRE culture, and then we had to talk. The idea was to talk to business and to introduce SRE to business. So you can copy paste this. I worked on this for 1 hour or something like that, and people helped me. It is an invitation for guys from business that was sent over email about what SRE is, what reliability is, and that we would like to talk to you. It's basically invitation for a reliability tech talk that we run in our company. So business now knows. And after business knows, we would like to discuss reliability and the reliability things with developers, TRs, and business. One by one, not everyone in one room. Why? Because we would like to get 3 perspectives. How developers see our reliability, how business see it and understand it, and how TLs. That 3 perspectives are important because you can be the neutral part there, standing just on the side and listening and seeing how they react and how they understand the things. Maybe you can help them somehow. As those reliability experts. Okay, and after that, you can define user journeys, and the best people for that would be business people, because business exactly knows how our customers use our services. So let's say they say, okay, so the first thing is that they enter the homepage, then they use the search query and they search for something, and then they have the list of something and they click and then they buy. Okay, so this is the user journey, nice. So now from this user journey, we need to create SLOs based on that user journey. So what to measure? Let's measure the time that it takes to search, so basically to generate the search results. Then let's measure the time it takes to generate the homepage, and let's measure the time or the number of requests of search results and opened the product pages, etc., etc. And based on that, you can define SLIs. So basically, how to measure it, to create those metrics. Basing on your monitoring tool. And we highly suggest like 3 to 5 SLOs per user journey, not more, because you will drown in the chaos and in the... okay. So how to convince business for this reliability model? I put some buyins, possible buyins for you. You can use it, copy paste, and try go one after another. Basically, when everything is stable, you can focus on the features development. That's the thing that business always like. Business will know before customers that something is going not good, and that's also a nice buy-in for them. Lower chance for unhappy customers also. Status pages for customers, you can sell that. I mean, if you have like GitHub has status.github.io, you can sell that. You can sell that. You have the status page, and customers can always see what's happening there. Dashboards with reliability information are also a nice thing. You saw it already. Yeah, and sometimes business may decide to override some decisions. Okay, so observability and monitoring. So we had this tool called Sentinel in Codewise, and we had some problems with that. I mean, when I started working there, and I had really huge experience with monitoring services, I saw that this tool has some issues. There was no HA, no check isolation, so basically one check could cause the whole Sentinel to be down. No pingdom integration. There were flapping monitorings because there was no possibility for muting, scheduling downtimes, etc., 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 etc. And so we pinpointed some number of problems, but our job is actually working on our products that gives us money, not working on monitoring tool. So one of the business decisions we made, and it wasn't that easy, was to actually start working on some third-party tool, start working with some third-party tool, and that's why we started monitoring with Datadog. Why? Because, as I told, we wanted to focus on business, not on creating monitoring tool. But we are Codewise. We had this performance monitoring tool already since 2012. It was called Hyperion Insight, and guys worked on that all the time in our VolumeDB team. And when we decided to work on Datadog, we knew that this is because we wanted to make some cleanup in our monitoring, how we approach monitoring. But afterwards, we wanted to move to something cheaper. And Tornimo, we published our Hyperion as a Tornimo, and yeah, it's basically quite cool too. Okay, the operational flow. So when we have monitoring, we may finally do self-healing. And for self-healing, we need automation. And for automation, we need strict procedures. And for procedures, we need operational flow. So I basically dug through all the operational procedures we have for Cassandra, for etcd, etc. And I took note which is scripted, which not. I put them in one place, put them into repository because not everything was in the repository. I decided to use one scheduler called Rundeck, not Jenkins, because Jenkins is not for operational things. And Rundeck, yeah, cloud agnostic with auditing, logs, credential store, etc. So if you are looking for a tool to run your procedures and to keep your store procedures, use Rundeck. Another things, use proper automation tools. Don't do Go, don't do Java, and don't do Python for automating what's happening on the file system, for instance. There is Ansible for that. Don't wrap AWS Services API with Java because there is Terraform for that, and it's declarative language. And basically in Python, for instance, you will snowflake the automation, and you will have to pay for that. And also always prepare for the inevitable future. So basically we gathered together and we thought, what might happen? Because it's gonna happen. And we put all those things like US cluster will fail someday, and whole cluster will fail someday. Maybe one AZ will fail someday, etc., etc. So we put that on the as our tasks, and we started working on it. Also, prepare for problems during outage. During upgrades. For upgrades, we have even postmortems already published. I mean, we tried to do upgrade of Cassandra, and we almost succeeded. It's not an easy thing because it's no rollback operation. We had huge problems with that. So yeah, self-healing creation kit. Bring all your operational procedures in one place. That's the first thing, because as I told, automation and monitoring, then you can think about self-healing. And if you automate procedures, then you can use manually, build trust, because if you automate some procedure, especially some tricky procedure, you have to trust it. And in the beginning, no one will trust. I met with this opinion that, Maciek, you shouldn't automate creating new nodes in Cassandra or replacing nodes because it's a tricky thing. You would like to do it manually. No way, but okay, wait a minute. So I prepared automation, and then I asked the guy, I started using the automation, and then I sold this automation, and now guys bought it. And I highly trust in that we will attach these automation jobs into the monitoring system, and this way we're gonna achieve the self-healing. And preventing recurring outages. As I already told, not always a postmortem, because postmortems are not always important, or full incident analysis, which takes days. Sometimes just enough to take notes and make sure it will not happen again. And the procedure is simple. Handle outage, analyze, take notes, reset. It's just that. Drills and workshops. This is very needed for SRE teams and for development teams. Why? Because it's cut down your MTTR to even 30%. MTTR stands for mean time to recover. So basically how long that outage took to recover. With drills, you can cut down this time. You can teach people and then they always know how to react. So run workshops and teach things. For instance, for me, from our Cassandra workshops, I realized that our automation sucks because people works on many kind of environments, on Mac OSs, on Linuxes, on Windowses, on whatever, with every configuration possible. And basically running an automation in Python/Ansible was not viable because people were losing huge amount of time to just set up the automation. Yeah. The wheel of misfortune. So it's just an idea. You can take all those scenarios you thought about, then you roll the dice, like in AD&D or something, and proportionally you hit one thing. And let's say the one person who rolls the dice, he's a dungeon master, he doesn't tell what was chosen, but he starts to describe what's happening, and someone or team or somehow starts answering and asking questions. And he tries to understand what's happening and then how to prevent that. And always note what could be improved in the process, because it's also measuring how the process is working, whether it's working fine or not. The process of fixing the issue. Okay, and Cassandra reliability notes. Just if you use Cassandra, and it's not that many of you, so let's skip that. Basically, there is a list we learned the hard way, and use that. Cassandra repairs is even more low level, so let's skip it. Operational tasks about Cassandra. It's actually screenshot from our run deck. So you can see that all the Cassandra related jobs like compactation, decommissioning, removing nodes, adding nodes, managing clusters, etc. and all the backups related things are in run deck. It's automated already. So no one has to run any CLI job from the terminal. He clicked there, we see, we have full audit, when it was done, how it was done, and why did it fail. Also about Cassandra, one of the most important things I did there was to give people possibility to spawn custom clusters. Basically treat Cassandra and treat any other database like any other service, like software. So if you want to test something with Cassandra, spawn a new cluster and operate on it. Import data from test or from prod or whatever, if you can import from prod, and work there. So it's one of the most important things. And I still see people that have just test and just prod clusters and that's all. So yeah, do that. So what for us right now means reliable enough? I would say that from one perspective, business is happy because customers are happy. And from the second perspective, developers are happy because they are not woken up. Cassandra doesn't trigger any calls. So I would say that this was it. We are still working on Cassandra SLOs, which is not a very easy thing, but we are almost there. As you can see, top charts are requests, requests per second, write and reads, etc. And bottom are latencies. This yellow one is 99th percentile because we base our SLOs on 99, 95, and 65 percentiles. I would say that it's this nice time where 95 percentile is like 2 milliseconds per write and like 5 milliseconds per read. It's really very, very fast, but we are still working on that 99th. Okay. And after this whole presentation, I would like to ask you questions whether, as developer, you still want to spawn your own MongoDB or Zookeeper, because now you understand how many operational related work is needed. It's the work you will have to do yourself, or you will give to your operations teams. It's not that easy. And some URLs you can see later. And actually, that's all. Thank you. Okay, I'm gonna see the questions which may be raised, but first I have to somehow exit this presentation and enter there. No. Okay. Do you have any questions? Okay, so sorry, room 10. Was DynamoDB considered as a Cassandra replacement? That's a cool question. Actually, when I was here, I mean, I wasn't deciding about Cassandra. Totally honestly, if I was there, I would make the same thing. Yes, it was considered and is still considered right now. We have our AWS services and customer technical, someone who actually helps us with some of AWS services things. And 1 month ago, we were meeting with him and we were talking especially about DynamoDB. I'm not sure what's gonna what's gonna happen right now, because moving from Cassandra, and it took us 1 year or even more to migrate from PostgreSQL to Cassandra, and that's completely another story. Moving back is not a easy and fast thing, and from business perspective, it doesn't give us anything. I mean, when we have this reliability sweet spot reached, then there is no point probably, but maybe. What do you think about Docker in terms of reliability? Wow. I gave already like 3 different talks about Docker. You can read about it. I mean, if you know how to use Docker, if you use just the basics of Docker, then it's cool. But I don't like it, and we have Cassandra under Docker, and I'm in the end of removing it from Docker. Why? Because Cassandra is a database, and we host it on virtual machines. There is no need to have Docker as an additional layer there. And every time something happens in Cassandra, then I have to get through Docker layer. For instance, when I'm investigating some network issues or something, I have to bear in mind that there is this Docker, there is IP tables, there is Docker storage, etc. It's additional layer, no need that at all. Are you worried about vendor lock? Vendor lock. Actually, we skipped the vendor lock. In terms of Cassandra, we used Cassandra 2.1, 2.2, etc., and we used DataStax software for managing Cassandra. We got rid of it, then we upgraded to 3.0 on test, and after 3.x on test, after upgrade on prod, we're gonna probably upgrade to 4. Something or whatever. We use Apache Cassandra right now, so there is no vendor lock-in as far as I understand this good. Okay. No more questions, so thank you all.